Hi my friend, welcome to Joey's Tech. In this video of Joey's Tech, we are going to work on developing the intuition to solve the longest palindromic subsequence problem using dynamic programming. So without wasting any more time, let's deep dive into the problem statement. So there is a string S given to you in our example. That is the example that we are going to work on. The string which we are going to work on in this example, it is going to be CBEDFEB. All right. We have to find the length of the longest palindromic subsequence from this string CBEDFEB using the classic dynamic programming technique. That means we need to find the longest palindromic subsequence possible first of all, and we are going to determine its length as well. Okay, now one thing which you have to remember is that it is a subsequence, not a substring. Subsequence can or cannot be contiguous. Okay, now for those of you who don't know what a palindrome is, then the palindrome is the string which is the same when read from right as well as from the left up to the center or pivotal character. Examples include radar, level, rotor. They are same from the left as well as from the right up to the pivotal point like T, V, and D in these three strings. Okay, now the answer of our string that we are going to work upon, CBEDFEB, you can see that the longest palindrome that is being formed out of this string is going to be BEDEP, and the length of which is going to be 5. Now we'll work on developing the intuition. We'll think together so that the solution through dynamic programming technique automatically occurs to us. Okay, so how do we approach to this problem? Let's start working on that. Before we begin, I request you to subscribe to my channel if you are watching the video of my channel for the first time, and hit the bell icon, because that way you will get notified whenever I release videos like this in future. So the approach, like I said, that we are going to work on the approach. Okay, so this is going to help you a lot, that you have to suppose that you are sitting in an interview and this question is thrown to you. Okay, simulation is very much important. That way you can at least know the pressure that you are going to be facing when you are sitting in an interview and a question like longest palindromic subsequence is thrown to you. Now at that point of time when this question is thrown to you, the only thing that you know is that you are going to be solving it using dynamic programming technique. And now the big question lies ahead. How are you going to approach towards solving the problem? And that is what we are going to work upon, developing the intuition such that this thing, the solution, automatically occurs to you. Now when this question is thrown to you, yes, your mind is going to wander in different directions and there are going to be many thoughts which are going to cross your head. Okay, we have to clench those thoughts which are very much closer to the solution. Okay, so we are going to work on making a list of thoughts which are closer to the solution. All right, so the first thing, and these thoughts are going to be random. Okay, and you are welcome to write anything that is coming to your mind, irrespective of the list which I am showing you on this video. Okay, the first thing which comes to my mind at this point of time is that I'm going to solve it using dynamic programming, the longest palindromic subsequence dynamic programming. So you are going to ask me, hey, this is so obvious, but it's a thought which is very much closer to the solution and I'm going to write it down. Okay, there is no problem, there is no issue in writing that. Okay, what is going to be my second thought? So 2D metrics. All right, so most of the dynamic programming questions, if you're going to watch other videos of Joey's Tech, then in solving most of the DP problems, I use a matrix, I use an array. So here it's a matter of a string, okay, and a longest palindromic subsequence. So I relate it to longest common subsequence. All right. So in that we need to make a table, and the rows and columns are going to be the letters of the string. So this is another thought which is coming to my head, and that is why I have jotted it down. 2D matrix and rows and columns to be the letters of the string. What is going to be my third thought? The third thought that is coming into my head is subproblems. All right. Now, when you are solving any question using either recursion or dynamic programming, subproblems is the obvious stuff. Okay, you need to break your problem down in individual subproblems, start solving them one by one. In dynamic programming, we follow a bottom-up approach. That means we drill down to the lowest subproblem and start solving our question from that subproblem. All right. So here is a structure that you need to focus upon and is coming into my head at this point of time. So this is our string CBET Now let's visualize the subproblem. So CB is going to be one subproblem. CBE is going to be another subproblem. Then BETF is also one of the subproblems. EDFEP is also one of the subproblems, and these are not the only subproblems. These are few of the subproblems. Okay, so this will help me in structuring my solution. All right, now what next am I going to think of? Let's pick up one of the subproblems and think over it. So I have this string. Now this string is a random string that I have picked up, ABCDB. This is not the same string that we are going to work upon, but if you see, now I have this string ABCDB, and as you can see that it is a composition of two subproblems, which is one of the subproblems is ABCD and another subproblem is BCDP. Now the length of the longest palindromic subsequence from the first subproblem is 1, and the length of the longest palindromic subsequence from the second subproblem is 3. How 3? We can see that there is a palindrome in the second subproblem BCDB. It is BDB. Hence, I can say that the length of the second subproblem, okay, is 3. But in the first subproblem, you can't find the palindrome because there exists no palindrome over there. So how the length is 1? Because every individual letters of that subproblem is going to be counted as the longest palindromic subsequence. Hence, the length of the first subproblem is going to come as 1. Now, like I said, that ABCDB is a composition of the two subproblems, and the longest palindromic subsequence, the LPS of ABCDB, is also going to come out as 3. And how we are finding 3? Okay, so if we think over it, then we are going to find that it's the maximum of longest palindromic sequence of the subproblem 1, which is ABCD, and the subproblem 2, which is BCDP. That is how we are going to get our answer as 3. So this is the formula for longest palindromic subsequence. We have done something, we have thought something over it, and we are progressing in the right direction. All right, but is this the only formula? There is one thing which we are missing here. What if ABCDB was a palindrome? That means instead of B, what if I had A? That means the string would have been ABCDA. So let's focus on solving that stuff as well. So here is one random string which I have picked up. Okay, just to think over it. Like I have now APA. Now it's a composition of two subproblems, AB and BA. But the formula which derives the length from the maximum of BA and AB is not going to work here because this is a palindrome in itself, right? So the first A is going to be matching with this A, okay, the last A. So there has to be something different. So what the length of this particular string is going to be? So it is going to be a plus a, that means 1 plus 1, 2, plus this length, the length of this b. So it is going to give me length of the string ABA is going to be 2 plus length of B. 2 is going to be the length of A and A, which is going to give me 3 as the answer because A matches A. Now, one important thing that is also coming to my mind, instead of B, if I had let's say a bigger string like BAC or whatever, okay, if I added 2 to the longest palindromic sequence coming out of that particular subproblem, I would have still got my solution. Okay, another thing which we are going to add to our list. So our list of thoughts now carries one, dynamic programming, second, 2D metrics, that means the rows and columns to be the letters of the string. Third is subproblems, obviously when we are solving any problem using either recursion or dynamic programming. Now we have formula to find length when it is not a palindrome, and we have formula to find length when we have found a palindrome. Now what's next? Is there anything which is left to be thought over? All right, so like I said that it's a bottom-up approach and we are going to drill down to the lowest subproblem. All right, so let's start from the smallest subproblems and think over it again. Now this is our string CBEDFEP. So one of the subproblem, let's go to the lowest subproblem. So the lowest subproblems are going to be the individual letters like I told you earlier. Okay, so C is one of the subproblems, then B is also a subproblem, E is also a subproblem. Similarly, D, F, E and B are also individual subproblems. Then moving on, we are going to have CB as also one of the subproblems and BE also as one of the subproblems. Similarly, we'll be having ED, TF, FE and EB also as few subproblems of length 2. Now, CBE, BET are also subproblems of length 3. Similarly, we have CBET, PETF and EDFE and TFEB as subproblems of length 4. So what I am thinking right now that there is some driving force which we are going to take into account, okay, using which we are going to progress with our solution, what that is going to be. Now in the previous slide I showed you that CBE is going to be a subproblem and it is going to be the length of the LPS is going to be maximum of LPS of CB and BE. All right, and this CBE is made of two subproblems, CB and BE. Now in turn, CB is made of two subproblems, C and B. That means our solution is increasing in the order of increasing lengths. It is progressing in the order of increasing lengths. That means length is one of the important driving factor. I'm sorry. So it gives me another important factor, length, which means that our solution will progress in the order of increasing lengths. All right, so our list of enough thoughts now contains dynamic programming, 2D metrics, subproblems, formula to find length when it is not a palindrome, formula to find length when we have found a palindrome, and as of now it looks as length is the driving force. I'm not sure, but we are going to just do the hands-on using all these thoughts and we'll find if we are able to solve the longest palindromic subsequence problem using dynamic programming. We'll do the hands-on in the next video. So with this we have come to the end of this video. I'm sure you enjoyed watching this video. If you like this video, then hit the like button. Please do subscribe if you are new to my channel and hit the bell icon. I look forward to helping you in dynamic programming and algorithms in general. Thanks a lot. Goodbye.